Yeah, in class I typically don't. Let me get captions so it gives me the file. Oops, before we do that. Hi, welcome back.
Somebody listening to say, "Oh, are you? You know how much you
Okay, so welcome to CIS 824B. I know most of you have been in my other class, the A, right? And if you complete ABC, you'll get the certificate. If not, you can also wait. Typically, we run these non-credit courses during the summer, or sometime we might offer in the winter. But we want to be able to learn how to at least set up basic networking for your home or for your business use through this class. And so this class is short and sweet. We're going to do Monday through Thursday. You have some hands-on starting today. Tomorrow, we're going to do a little bit of physical cable making. So in the case if you need to run cable for your home, your business, or just personal use, we'll be able to do that. And I'll supply you with the connector and the cable. So it's going to be a little fun. And then we'll have some sessions. So basically, this class summarized a typical class like CIS-40A, which is the Network Plus, but it's going to give you like the very basics. So in this class, we are going to learn, as I mentioned, how to maintain your network, how to set it up, how to do troubleshooting. Everything is interconnected from the time that you turn on your smartphone all the way to when you go to Shell or gas station or 7-Eleven to pay, right? Everybody is interconnected, and we are on TCP IP network. So we'll talk about what really consists of a network, how does it work. I started looking into like the AI network, like at data center, they're using different set of protocols and things like that. So that's going to get integrated into some of the technical classes as well. So in this class, we're gonna do the hours for the lecture and the lab. Just on Thursday, I won't be able to stay the entire session because I have to travel for family matters. So I will do the lecture, and then after the lecture, you won't have the lab. The lab will be incorporated into the other days. So we'll end a little bit earlier than our typical hours. Instead of taking bereavement day, I can't do that because your class is so short. So I wanted to kind of give you the lecture. But so starting from today, you are going to learn about topology. So topologies is kind of like the layout of your network. And topology is really important. So some of you will be pursuing cybersecurity, and network design is a crucial area in that, only because no matter how you design your network, there's always going to be a flaw. So it's kind of like building a house, right? You really have to think about like the foundation of the house and where the rooms are being laid out. So we want to be able to look at it, like your typical layout of a network, how the system would transmit data in different layout. And in security, when we look at that, we would look at like the downside, like the impact that is negatively for your systems depending on the layout of your network. So we'll be able to design a network today using a software tool. So we'll do a logical topology. And then throughout the class, we will touch on like what systems would be connected to become a network. So we would look at your computer system, but we would also look at communication systems. And then we'll talk about like the larger network with like autonomous system and your service provider, like AT&T, T-Mobile, Spectrum, Charter, etc. Right? But in the scale, we really want to focus on networks that make sense to the personal and the business use. So then with that, we would talk about addresses, right? Like your system is just like a home. We want to be able to get the data to it or retrieve the data from it. whether you are watching YouTube or you are paying bills online, right? All of these systems have addresses to receive your information. So the routers is like the system that transfer all of that. So it's kind of like I always say that the router gets you to the exit of your home, right? But the switch is what takes you from that exit to your street. So it has different types of systems that carry your information and bring it to your computer where you're sitting instantaneously, right? Now we're on a TCP/IP network that we are interconnected at much faster speed in North America, right? But if you're looking at different part of the world that is still developing out their communication system, it might not be in the same, right, standards or guidelines. So we'll talk about addresses, different type of addresses that your system use for communication. And in the network environment, we will touch on OSI layers and protocols. So protocols are like the set of rules. Just like at home, you have a set of rules. Like, for example, Saturday is chore days, or if you're a parent, you tell your kids to do a certain thing. So the system have a set of rules that they follow for communication. So that way, universally, if you have an Apple system like a Mac OS or a Windows system or a Linux system, they all talk the same rule. So that way we're not using variation. But you also have specific rules for certain proprietary systems, and like Cisco technology, right? They use a different set of rules. But in a worldly environment, you would have a universal rule that those systems also agree on. So that way you can buy any kind of appliances or system so it communicates. And then we'll talk about ports, how your system send, just like how you have doors and windows in your home. This is how you can enter a home, is through the doors. Those are the ports, and that could be physical through cable connection, or it could be a logical port. A lot of your services, like your web services, it still come back in electrical signal, but it uses like a window. Think of it like a value to determine what kind of service it's using. So, and then when we're troubleshooting networks, how do we go about doing that? Just like how we would troubleshoot a computer. And then if you want to upgrade your network, like at home, I want to be able to have more security in my network. I want to be able to have a server that I'm streaming media in my network, right? Like movies, or maybe an auto sync. So whenever I enter my home, I'm able to upload all my images and videos on my phone into a repository, like a server environment. So we'll talk about like options to be able to scale and upgrade for your network. So your objectives are here, just to really understand the functionality of systems and network technologies, and to be able to troubleshoot it in case you run into problems, right? Networks makes the world go round. Without networks, business will not operate. So before the security area is really the IT area. So a lot of my students, they just want to focus in becoming a technician or an analyst or an administrator in this area. And there are a lot of jobs specifically for this, right? And so, and then if you want to build out a network for your business or home or upgrade it, you can. Now, I don't use a textbook. Everything is provided on notes and it's included for each module. I recommend that if you want to use a textbook, this is an older edition. I think they're on the next certification. In 40A, I usually update the editions. So what's the difference between one edition and another edition, like edition 6 compared to the 4th edition? Well, the certification, they added about 100 questions for each round that they upgraded. So it's been 2 certification in, so 200 questions get added. So originally there was like 900 or 1,000 questions, and now you just have more questions. And those questions related to new network technologies, possibly new protocols and rules. But networking hasn't changed the protocols that you were talking about today and onward, it's been around since the 70s. Yes.
Is it available in the library?
Yeah, I think I dropped a couple of my desk copy that the publishers had sent me. I left it in the library. I gave it to them a while ago, so you can go and ask. I did ask the library because they had like $10,000 to spend in last fall, and I did ask them if they can buy some extra stuff for the classes that are, that zero textbook cost. And they mentioned they would. If not, I can ask them again. However, you can use the notes and it's relevant. I think now with AI, you are fully capable of doing a class without the actual textbook, right? Because everything is on the web and AI scrapes the web, right? All of this stuff is not really new to us. It's been around for a long time. So someone can definitely go through and prepare for certification without the actual textbook. Publisher might not like it, right? Because that's how they make money. But ultimately, the broader knowledge, there's a centralized knowledge base which is the internet, right? And so we kind of have to adapt to that. But if you would like to have books, this is an old edition, so you can probably find it used for like a few dollars online. Or sometime if you have Kindle, you can download the old edition for free sometimes, right? So get the notes if you want to kind of look at that for your assignments. I do take late assignments. Unfortunately, the class ends on Friday. So the last day that you can submit your work for this class is Friday night, 11:59 p.m. I need to get the grades up by Sunday or Monday, right? And then for the last class, I still have to release the badge. So I will send that into the system. So there's no final exam midterm for this class because it's short and sweet. It's really, I assess you based on like your participation, your capability in absorbing the knowledge and what you're doing in class. That's basically for the non-credit. So we will have some in-class assignment. I will do that with you together. So in case you have questions, you can ask me. And I do this for all my class, including the online one. And so if you can finish it at the end of the session, great. If you don't, just make sure you submit it by Friday. And if it's because it's due on Thursday, technically that's the end of the class. I don't ding like when it's one day late or, in my online class, if they turn it in 2 days late and they let me know, I don't really ding the point. So you will have one quiz in this class and it is shorter than the last class. I think it's 20 questions, 5 points per question. And it really entailed the review of all the assignment questions, all the things we've done in class. So it kind of helped you go back and think about what you have learned. And so we would want to be able to complete the quiz. Okay, so quizzes are 20%. Only one quiz, so don't miss it. Your in-class assignment is 30%, and your attendance does count. So I will typically take attendance in the second half or sometime in the lab or at the end. So that way if people arrive late, they still get counted. Our lab activities, which I demo and include you as part of the process, is going to be 30%. There's going to be a project. I'm still kind of trying to think about like how I can do this without having you, put in the extra effort to really look at stuff, but you should put in some effort. I might introduce you to Packet Tracer, which is a simulator that we typically use for configuration. And then I will walk you through the very basic step on how to use the simulator. Packet Tracer is regularly used for people who are training to, become a network administrator or technician. It also is used for Cisco certification preparation. Some of you might be familiar with it. And if you have taken CIS-26 series at RCC, you have used Packet Tracer. We have it installed on the system here, but you can download a free copy if you register in Netacad, which is free. And we have Cisco Academy as a partnership with us. So it's really geared for Cisco technology, but as you see now, Cisco is used, but it's not in every business, right? So I wanted to make sure that you understand that you don't have to have a Cisco certification to work in networking. It's a plus. but it's good to kind of have the knowledge in case you need it, right? So I might introduce you to the tool for the project. All right, let's talk about attendance and participation. So if I don't hear from you for a few days, which is the majority of the class, I do reserve the right to drop. I think they sent a notification for like dropping the class without a W, but for the non-credit, you can always retake the class as many time as you want if you haven't completed the class. But my typical rule is like 2 consecutive absences. That's a concern. So yeah, if you have problems, just let me know, right? And then I follow the college policy for behavior issues. In my 21 years of teaching, I only have 1 incident, but it's not at a public school, it's at a private school, where I have to remove the individual with security guards. But overall, like, we're just gonna operate in a respectful environment. So if you have problems, let's address it. And you can talk to me, right? If there's another student that's involved, then we can discuss it, and if it needs to be escalated, then it can go to academic affairs and student services. I typically don't have these problems, right? So, if you have issues, just bring it up to me, we'll talk. All right, just do your own work, right? And I mentioned to some of you that like I do check, especially for programming or other advanced classes, I put it through AI to check for AI. I also put it through AI to check to see if they copy and paste stuff, especially with code, right? I get a lot of stuff coming back like, oh, this came from this, right? In university, they take this matter seriously, that they would dismiss you from the university if it's copy paste code. Berkeley says that 60% of their students cheated on their math exam in the first year, right? Statistically. And so, just be mindful of whoever created the work, even if it's AI, right? Like a programmer actually program AI to do that. So if you reference things, just make sure that you put in where you got the information and so on, right? But for this class, most of the things we do might not be relevant to this, but that's just standard policy for me. If you need accommodation, make sure. So the way this works is if you take MVC class, you need to talk to MVC, even if you RCC or NORCO student, right? So you can visit their center, you can contact them via Zoom, you can call them. Things like, I need a screen reader. Things like, I need a special computer to take tests. Things like, I need, a little bit more time to take her quiz. So they will send me a letter and I will accommodate that accordingly. So it's really geared to help you be successful in your school. And you can do that for every single class that you take. And that's included as part of your college experience. Okay, best way to communicate with me is via email. I do respond fairly quickly. I check it throughout the day. If you call this number, it goes to my desk, which I'm rarely there in the summer. If you need to have an appointment to talk about class or other things, we can do it in person before class or after class, or we can do it via Zoom. Just email me. And then if it's Zoom, then I'll send the Zoom link for you. I typically respond to everything within 24 hours. So, and you can send Canvas message as well. It doesn't have to be email. Any question? Okay, so with that out of the way that you access this class, if you're not sure, right? So you would access Canvas. This is where all your assignments are included. I also included resources for you. So if you want to get into apprenticeship so you can get some work experience, you can click that information and then it'll list a certificate that you can go through and sign up. And then if you want to get Network Plus certification at the end of this course, I have free voucher. Network Plus is not an easy test. I'm going to tell you, a lot of students pass Security Plus on the fly. They're going to pass A plus, because it's 2 tests. But a lot of them tend to fail Network Plus because it's a harder test, right? But if you want to pursue it, email me. I will give you a voucher. All my vouchers expires on the 31st of August. And then we will see if we have more money to buy vouchers. I'm working on grants to be able to fund it. But if you pay for this out of your pocket, it's typically $350 without discount. And if you sign up with CompTIA, I think they give you a little bit of discount. So it will be roughly like $200-300. And then it's 90 minutes, 90 questions, right? And you have to pass it with 80%. Many of my students also pass Network Plus first time. It doesn't mean that they fail every single time. And a lot of them took my 40A and they passed at the end of that class. So you can study for it, but having this is gonna probably give a leverage for you to step into the networking positions. Remember why I said IT first before security? A lot of companies hire IT before they hire security. So, that's something to consider. Email me if you want voucher. Okay. All right. So the notes, you can click this page and it will take you to the embedded note information. And then you can also download it using the arrow key, right? And if you need USB to save, so you can just get a USB from upfront. And then if you click the next page on here, it will take you to the assignment, which is what we're going to do now. Okay. Any question? Okay, so my lecture entails answering these questions. It really helps you see, hear, and type so you remember, right? I want to tap into like all different type of learning. So I wanted to make sure that you understand the terminology. The hard part in IT and cybersecurity is to learn about the acronyms and the terminology. So once we have that out of the way, everything else is easy. Okay? All right. So in your notes today, it starts with defining a network. So in the first question, it asks you, what is a network? Of course, you can ask AI and get AI answer, right? But by definition, network really consists of two or more computers connected. Let me see if I can zoom in a little bit better. Am I at 200? Yep, max. Okay. So anytime that you have two or more computers connected to share resources, to share files, to provide service, and typically your data comes from applications, right? You might have like, let's say I wanted to create documents, so I might have Microsoft Office, and I want to be able to send from computer A to computer B. And so that way we would have some kind of interconnection so that way we can share resources. Now, network doesn't necessarily consist of computers like workstations, desktop, or, it could be, as you know, mobile devices. It could be autonomous systems, right? So when I say autonomous system is very common in communication. It's basically systems that is automatically doing something like forwarding data to the next system, or to be able to auto-generate some kind of data or other things, right? And we started to see a lot more of that when we're looking at artificial intelligence and robotics. So it could be a group of printers, right? So in some cases, we would connect the system together so that way we can share resources, we would share services, or we would have communication. So the internet is really consists of many networks connecting together, right? When you see a website like youtube.com, that's really a domain. And domain consists of a server for web and also for resolving the name. So we'll touch back on that in a little bit. So in any cases, whether you're doing payments at the grocery store to when you are at home using your network to play games, right? If you're a gamer, then you're using a network. So the network can be in different scale. Now, when you're looking at a job, let's say I want to be a network technician, or sometimes they call it, like IT technician level 2 or level 1, you typically see the acronym LAN for LAN. And that really consists of local area network. Basically, it's a network inside the business, like where you're sitting right now, right? This network belongs to the school, to our CCD. So it's really restricted to the geographic location. So when you go to work, let's say that you work for a retail store like Walmart or Costco, their network, right, their LAN is to that location. But wait, you have enterprises, right? Or you have banks that are in many different geographic areas, their branches. So you would have the physical location, branch 1, that will be connected to their corporate office, and so on. So it can span in a bigger environment, but the way that we're interconnected is through the router, or when you leave your wireless router at home, you're entering into the service provider network. That's considered a WAN. So a LAN is really to the local area, right? Like a business that would have their networks consists of computers, printers, servers that's inside that business, right? Like what we're talking about inside our school. So that way you can share printers to print, right? Like if I have a real estate business, I might be able to print documents relating to real estate for my buyers or sellers or renters, right? I might have laptops and mobile devices so I can show homes, right? So like tablets, sometimes laptop, you have a lot of mobile workers these days. So since the end of COVID, we would see a lot more remote work or hybrid work environment. And that really pushes us to really scale, a remote type of environment for every single business. Any questions?
Yeah.
Yeah.
I just didn't hear, what was WAN again?
So wide area network. So anytime that you're entering into the internet, the cloud, or when you're leaving your router to go into another network, right? It's kind of like how we can cross the border to go to Mexico, right? Or TJ, Baja California also, right? When you're leaving the United States, you're entering another country. So when you're leaving your local area network, you're in the wide area network, and that's considered, right, somebody else's network. So the way that the internet really consists of is you have many networks connecting together, right? Like my home network is connecting to my service provider, and you can be like having Spectrum or Frontier or whoever that you subscribe to. So that means that when your data it leaves through your router, it's going to enter to your service provider, and then your service provider is going to then send to their larger network, and then eventually gets to Google.com or YouTube, which is also another network, right? So, and the reason why it's so fast these days is there's a lot of push, as you know, for fiber connection, right? So the type of cable that you use is going to give you the throughput on how fast you're going to receive or send data. Okay. I think we touched a little bit on this if you took we talked about like Ethernet is faster than if you connecting wireless. And fiber is the fastest, as you see. There's a huge amount of funding that goes into city and state that is implementing fiber. As you know, fiber is not everywhere in the United States, but it is now growing, right? Because fiber technically was expensive, but now definitely there's resources for people. So if you buy a new home these days, right, to your home is fiber. But if you live in an old area like me, right, you're still using copper, which is the cable connection with the needle. We're gonna make that the coaxial, right? And then in the more rural area, you might be using satellite or phone line DSL still, right? Because they don't have actual physical locations out there with service provider. I have a family member that lives in a very rural area. It's a very beautiful area. And there are two options they can get, DSL or satellite. And if you know, days like today, cloudy days, satellite signal is poor. Okay. And then if you're next to big trees and mountains and things, satellite can become a problem. But I'm sure you probably heard of other satellite technology. That's the claim, is that you can get connection to their satellite anywhere. It's questionable. It's line to sight. So marketing is always so perfect, right? But in realistic, we really have to really look at like when it's not connected. Okay, so in an environment, and typically you see this in Windows systems or even in like a more of like computer connecting to computer, there's a thing called work group. Work group been around for a long time, since, I don't know, the 80s and the 90s, where the devices are in the ad hoc environment where they're just connecting to another. So for example, I might have a work group at home in that I am airdropping from my iPhone to my tablet environment, right? I'm just sharing files that ways where it's device to the device. There's no context in security. Now they implemented a little bit with like pairing devices and so on, or near field communication system. But as long as they're on the same network, they're able to communicate with one another. I'm able to obtain files, or I'm able to get some kind of services or resources. So you might have like companies that would have work groups. Typically we advise against that because there's no control in that, right? In that, where all the systems doesn't have to authenticate to a server to obtain some kind of service, there's no centralized system controlling them, right? It's kind of like you hang out with a group of friends and you just sharing food with your friends. There's no one giving, like one food source, right? Where if you go to a restaurant, your friends would have to order the food from the kiosk, or the waiter, the person that serves the food. So in a work group environment, everybody's kind of equal. Any question?
Yeah, just one.
Sure.
When you use iPhone and you use iPad and you have a Mac, sometimes I bought extra memory, and if I take pictures, they will tell me every day.
The same.
How do you know? That was my question. Is that considered a network?
Yeah. So basically it puts everything back to your iCloud account, right? Which has a storage at their server, at Apple servers. And then, so in the case that if I add a new contact to my iPhone, right? Or when you do that, right? And if an hour later, you're using your tablet, you're able to see the same information. It is a centralized environment, and you just putting it on the cloud, which is a remote systems that store your information. So that way we don't have to repeatedly add the same contact across. Because when you do that multiple times, what will happen is that you might type the wrong number, you might type the wrong information, so it eliminates the error. We've been doing that in a regular business network environment for a long time, and now they're implementing it for personal use, and I think it's good. Now, the downside of syncing is that your data is centralized to that account, right? Let's say that you pay for the storage and you don't pay for the service anymore. They do have the authority to control your data, right? It's kind of like you rent a car and then you stop making payments on the car. Can you still use the car? Probably not, right? And then they also store your data. So in the case that they have security issues, then it becomes your problem as well, right? So you take that risk. in using that kind of service. But it's good to kind of back it up to the local system sometimes if you have like pictures or files. Okay, so what is a workstation and how often are how is it used, right? So workstation is kind of like where you're sitting. It's a computer system that is used for work, right? It's typically have a little bit more hardware, like memory, storage, processor to be able to help the user do their regular business. So workstations are very typical. Is it a desktop? Yeah, it's kind of like a desktop, but if you go onto Dell website or Lenovo or one of the vendor and you search for workstation, it typically is a little bit higher in price because it's supposed to last about 5 years. So we don't cycle through technology, right? Typically the lifespan of it is like 5 years, sometimes longer for some company, how regularly it's used. So it's really made for business environment. So let's say that I go to the Dell website, right? You can press Control and click it. And you can look at their options, right? Why am I using Dell? Well, Dell is a very common technology provider for a lot of businesses. And when you buy bulk, you tend to get more discount, right? So if you press Control and click the link, it's going to open it up in Bing or Edge. No, sorry, I clicked out of that. Let's do that again. And so when you see it, you would see that your mobile workstation, which is like a laptop, right? It's much higher than your regular consumer laptop for sure. When you read the specification, you can probably find something comparable for the consumer that's a little bit less. So for the business, right, they would usually add the hardware that you would see. So in the case that if we buy the workstation that is desktop oriented, right, you can look at. So their Pro Precisions type of systems, as you can see, right, it comes equipped with specific hardware. Okay. So what I want you to do is I want you to check them out, right? So let's say I want the Pro Precisions desktop. I would click the link and then I can look at the specifications. So there's different model that it talks about, but you can have a very large storage capacity, right? You also have graphic capability, which is NVIDIA there, okay? And then you also have processors that is higher rated, okay? So you can just pick one type that you see that will be adequate. Now, businesses don't have to go with Dell. They can use like HP or other brand or Lenovo, right? Depending on how, what the preference would be, how much they want to spend. So there's a lot of aspect, but I typically advise like for people who are building their network on an existing network, you stick with the brand because that would be basically your service warranty. That way you don't have a bunch of different vendors in the case that your system breaks. You can have it mix up, right? In the case that you don't like a brand and you want to kind of take out all the old system or leave some and then be able to add new ones in there. But it's just the challenge will be that your service warranty is going to be multiple people or businesses. So we can just pick a type of your choice. And then we know that it is different than your regular client PC for sure, right? Or sometimes very close to the same. Any question?
Yeah, when you're using the premium laptop workstation, is it how do you integrate that when you're traveling, when you're out of the state or country?
So you will probably have to use some kind of SIM to be able to connect to the network, and you're gonna have to have VPN. It's just for security. You have to have it, right? So security is more of a choice. Um, it's kind of like, do you buy insurance when you travel? Right? So the people who buy insurance for their travel, likely that they are gonna want to be more secure and protected when they are connecting to the mobile network. So you can get some kind of hotspot through the service provider at the destination country. You can also buy VPN connections, and you can subscribe to them month to month or yearly. But can you still go without it? You can. Like I said, right? You can travel without travel insurance, but in case something happens, then you're not covered, right? That's a risk that you just have to take. Now, if you buy a higher end system, you should protect your investment for sure. The way that we look at it is it's a capital investment when it's over $500 in a business environment, as you probably know, right?
The reason I'm asking, what I'm used to when you think about a workstation, I think of something like a desktop that is there for the printer. But then when they say it's a mobile precision work.
Yeah, so the terminology is loosely used now that we just have more mobile worker. So workstation, traditionally, it was really geared for the desktop, like the physical tower with the monitor. But since we've been using a lot of like remote network for mobile work environment, like you can work from home half of the week, or you can work from home 100%. In the technical industry, it's very common to do remote work 100%, right? You can hire someone to write your software and they work somewhere else in the world, like in Mexico. So yeah, so now they're labeling mobile like laptop systems as mobile workstations.
So you don't need to buy something different like docking station.
Everything
is included in the laptop.
Not necessarily.
Okay.
So they'll also sell docking station on a separate page. So if you buy, let's say I have 1,000 employees, I buy 1,000 laptop for my employees because they might be traveling throughout the week. I'm gonna have to get 1,000 docking station, but now it's just a little box with USB and a charging connection, and then I would just put it at their desk, right? Or I can give it to them to take home, and then they'll just dock it at home. But that docking station, I need to also configure it as part of the network, so that way they can connect to the network for like encryption, for resources, services, software, etc. Yeah.
Thank you.
Yep. Okay, so let's talk about a different type of system now. So as you go through, right, you would see, so we're going to touch on servers now. So I kind of, we're going to draw this in a little bit. So we want to kind of understand how, how it is really being used. So the servers is on the page 2. So servers are just computers that is providing services to other systems that are connecting to it. So I can have a servers that typically store files. And so you see this, right? Whenever you're using OneDrive, when you're using your Google Drive, right? Those are actually file servers. So you're just connecting through Google Web Server and authentication server and other things. So within that, like when I upload my file to my OneDrive or my Google Drive, typically I would use multiple server. Now in Microsoft environment, they relabel file server, they call it storage server. Technically that's more correct, right? So file servers, basically it stores file for you to download and upload. Many things have file servers. YouTube have file servers, right? That's how you upload and download videos, right? Dropbox have file server. You use Dropbox, which is typically what you see with Google or OneDrive as well, right? So a lot of the systems that have your files, Even social media have file server. That's how you upload your videos, your pictures, right? And so on. And it keeps your messages as content. So file servers are essential in operation for a lot of the businesses, enterprises to small business. Then you have mail server. So I'm going to tell you the majority of the business use Microsoft Exchange, which is a product for mail server by Microsoft. Like I mentioned prior, and you might know this, right? If you use Microsoft product, you are going to pay per user license. So if you have 10,000 users, you pay license for 10,000 people, right? They call them seats. Now, can you use other products that is not Microsoft? Sure. It's less common. So as you are logging into your email for school, you would see that it is through Outlook, right? And Outlook is a product that Microsoft supports. And so we can use a server. So what the mail server does is it stores your inbox, right? Things that arrive to your email account. It stores your drafts, things that are you still editing before you send, and it stores your outbox, things that you have sent, right? It also is a post office system where it would send your email from your account to other accounts. And you would have many mail servers in between to do that, including your service provider. So let's say that I use my RCCD account and I'm emailing someone that's not in RCCD. It would use my RCCD mail server, and then it would also use service provider mail server and the destination server that receives the email. For example, like somebody is using Gmail account. And then we have print server. So this type of server allows you to manage your print. You typically see this if you go to Staples or, those office supply stores where they actually have it. But most businesses have this. They control ink usage, how many pages you can print. Schools here, they might have that. So that way, because sometimes you have to pay per print. So in a business environment, you want to have a print server, but print server can be a Windows client system or a server operating system. It doesn't have to be server only. So it manages printers on the network. So when the ink is down, like it's low, or when the printers is down. And then that way you can also cancel print queues. In the case you don't want them to print, you can control which system can print. So there's like a lot of things, right? Ink is a very expensive, ongoing supply that a lot of business face. So what you see is that like they control that. I had worked with companies, or I was a network administrator when we implemented a lot of the print servers. And my supervisor used to tell me like, you need to really control who can print and what they can print, right? If you drill it down to that level, right, like you can reject someone from printing if you don't want them to carry out that document, because people can print social security number of patients and clients and customer and walk it out, right? So in a paper-free environment, a lot of times we control that on who can print and what can be printed. So if you have a billing department, of course they're going to print because they print receipts. But if you might have others like, that you don't need to print. So these are just some example. Web servers, when you see this when you visit a web page, right? So my students, sometimes they have a hard time understanding what's the difference between a domain name server and a web server. They go together, right? You cannot have a youtube.com without a DNS, a domain name server, because that resolves a public IP address that's given to that system to the URL, okay? But a web server gives you the page content. That's like HTML, JavaScript written. So that way you can log in, that way you can download, that way you can watch a video. That's a web server. Web server is for web content. So in the case of when you are visiting a website, you are using both, right? A domain name server, so you can reach it with the URL, and then you have the page loading, which is the web server. I'm going to tell you a lot of the security comes from this guy, right? Because everybody can reach it. So if they wanted to take you down, that's the first target that they're going to see, because I can reach anybody that's on a public domain, right? Like, but if you protect it, then because it goes from this into others, right? So typically this is on the DMZ, and that's for the next class. But so kind of understand that servers are just like a systems that provide services. Back in the day, and you still see this in public school, if you ever hear the announcement like, so go to principal office, right? They still have telephony systems that uses, like, that's how they can send it to all the rooms or specific rooms. And then you also have application servers. So I can control what kind of application is being used. Like if I don't want people to use Chrome browser, I only want people to use Edge browser. Or a specific application for my business, I can use application server to do that. You guys know what a proxy is? Some of you do. This is really important in security. So proxies are like the police officer that guides you to the detour, right? In a sense. So let's say that you have an accident on the freeway and everybody has to exit, and there's a police officer saying, merge the lanes, right? And then exit. So proxy, we can use it to regulate traffic. For example, I have users that are just surfing the internet. I'm going to guide them to this direction, to the first exit. Then I have another proxy for essential businesses, maybe finance, billing, loan application, submission, another exit, another row, right? So in a enterprise environment, you have many proxies, many ways to get from point A to point B. The reason why we control it is that we can monitor, right, who's doing what. And then we would be also diversifying, dynamically sending people to the right area quickly. Because if everybody goes to one exit, one road, it's going to be congested. And you don't want latency and congestion in the business environment. Understand? So that's a system that forwarded. So if you ever go to public school, like grade school, you know they control on what website you can visit, right? You cannot just watch YouTube all day. They block that. And they do it through two things, firewall and proxy. So the student side of the house, they send it to a specific proxy, and that proxy is used to screen. So when you type in a URL, youtube.com, and if you're under 17, right, because of the regulation, then it's going to say, nope, access denied, right? But for the faculty there, if they want to show a YouTube video, they're on a different side of the network that their proxy is able to do that. But there's ways that you can bypass this, right? That's another thing. So, but proxy is used for that. Every system can be a host. So you can say that server is a host. Now you don't have to put all of these in. You just need 3 or 4 server, and you can copy and paste it from the notes document, right? We talked about that. Sometimes they have a fax server. So why do we use fax? And fax uses landline, right? I had to fax something the other day, and I was like, oh, I have to go to a center to do that because I don't have a landline anymore. Most people don't here in the United States, right? So you use the landline for security and fax purposes. So back in California, there's a lot of requirements in documents using wet signature. When we say wet signature, is you have to actually sign it with pen and paper. Loans document, real estate documents, any kind of agreements in financial area, you have to do that. So you have to fax it to a certain entity, right? Okay. So for a host can be laptops, it can be your tablet, it can be your servers, it can be POS, stands for point of sale system, where you tap your credit card or do Apple Pay or whatever that you use, right? So point of sale systems have to be connected to the network, or if you're using Square, where you insert your credit card into this tablet device that has a slot to accept your credit card, right? Or your debit card. So all of them, right, connect to the internet using what's called Transmission Control Protocol and Internet Protocol. TCP/IP. You see this in a lot of technical jobs, right? So TCP stands for Transmission Control Protocol. And Internet Protocol is used for addresses. It's specifically used for routing purposes, like getting from your network to the next network, right? So the router uses Internet Protocol to find where it's supposed to go or who's supposed to receive. For Transmission Control Protocol, it makes sure that it gets there intact. It does three-way handshake. One, it's going to acknowledge who's sending and who's receiving. So let's say that I need to send you a package and I go to the post office and I say, I need to send so-and-so a package. And I need a verified signature. That's what TCP does. So it's, before it sends, it's going to say, hey, I am system A, and I'm sending to you, system B. Are you ready to receive? And the system B would say, okay, I'm here, I'm connected, I'm ready, right? Then the system A is going to say, okay, I'm sending now, right? So it sends, and then system B is going to say, ready, receive, right? It's received. So in that, you have communication in those systems that are sending and receiving, so that way your data will get to where it's supposed to get, okay? Now, it uses the IP for the addressing, so it's kind of like how it's gonna detect which home address that package is delivered to, okay? So, unlike TCP, another protocol, it's just gonna be like, I'm just sending. If it gets there today, tomorrow, 5 weeks later, it gets there, right? It doesn't need any kind of verification, it just sends. And eventually it will get there, right? So when you're watching a YouTube video, you're actually using UDP, not TCP. This is why sometimes you see that little circle waiting for your data to still arrive, right? So it's buffering, and then it will load the video, especially if you're watching stream, okay? Now TCP is different. It puts everything back together, and then you would see. So it takes a little bit longer, bless you, but it is definitely more reliable. So this is what we're using now for all communication, text messages to phone calls, right? So if you are Wi-Fi calling, I told most of you this, but I'll talk about it again. It goes to an encapsulation of data process. So when I'm connecting to my Wi-Fi, I dial a number, I call, my voice gets converted into digital, and it sends it to whoever that's receiving that phone call, right? And it's able to open so they can hear my voice. So their system, their phone, takes that and decapsulates it and convert it into sound wave, okay? But everything goes through digital 0 and 1s, and it goes through the network, the mobile network. So you would see that the larger networks uses TCP/IP. Can we do it with other protocol? We can, right? But then you would hear a lag, like you saying something, and then they'll get like 2 seconds lag. They're like, what? And then you're saying something else already. So we want something that's reliable in communication. Any question? Okay, so let's look around, right? For the internet, we are going to look at some systems that we can connect together. Okay, so we are going to start with the router. Okay, I wanted to introduce you, and you're most familiar with a wireless router. But beyond the wireless router, we have a physical router that uses cable. So all you have to do is open your browser, go ask Google, right? I'm going to look for router. Okay. And likely that you're gonna get variations, wireless router or even small home router. A lot of the time, if you have a very small business, you can use, right, business grade wireless router, right? It is similar to what you see for your home router that you either lease or buy from your service provider. But I wanted to point to this, right? You might see something like this, okay? Where it would have Ethernet connection only, sometimes fiber only, or old school would be coaxial. So what is the router? The router is a system that takes your data from your network into the next network, right? So we can have system A sending to system B in different networks, okay? Now, routers are not being used. Actually, yes, we can say a switch or level 4 switch or router. Router can also be used to segregate different type of network. So I have finance department can be separated from my, maybe sales department. So you can separate them inside as separate networks that way. But you can use a switch that function as a router as well. So you can find something like this, right? On average, you would see that it would run a few $100s to several $1,000s. It depends on who and what and features you buy. Yes.
Oh, are you saying that it'll be the same network but on different routers or two different networks?
Yeah, so the way that we do it is logically it's the same network but segregated.
That's it.
So kind of like I have multiple departments and I don't want them to intercommunicate it unless they go through the main router. So it's like you have people live on different streets and you force them to go through the main street to get from one street to the next, right? Or force them to go to the freeway to get to the next street instead of going from one street to the next. So that way you can control on who is communicating across the different departments. You see this a lot when you deal with like sensitive data. So the way that we do that is we can logically use IP address, right? And every time that it is in a different subnet, it has to go through a routing process. Okay. It's kind of like we segregate the town into many zip codes, right? In order to go from one zip code to the next zip code, we make them go through the freeway, which is the router, or a switch that has that routing capability. Okay, so once you find a router, you can implement like the wireless one. We can look for the next one, which is a managed switch. So a managed switch is different than your regular switch in that you can configure it. So as you can see, the old Catalyst here, it's $6,000, and that's typical, right? You can also see something like this, $14,000, and they can go higher, $70,000, $100,000, depending on what kind of features, what kind of capability, just like how your computer is. Know that all of these appliances have processor, RAM, and sometimes larger storage, and operating system. A lot of them run embedded Linux in the back. So like Cisco technology, they have command line interface, which is similar to what you see with command line in Linux, and they use specific command for Cisco. Okay. So in variation on what we need, right? So that means a managed switch has an interface for someone to go in and configure it, compared to an unmanaged switch. It's just something you plug in and it's able to get your system connected. So for example, I have 4 computers I wanted to connect. I can buy a switch that has 4 or more ports, like 8 ports, and connect them with a cable. And the switch, its job is to make sure that computer number 1 can send data to computer number 4, right? A managed switch, you can go in and configure. Only computer 1 can send to the rest, but the other ones cannot send. So that's how you can control it. So in an environment, like a business environment, you have both. Okay. So find a managed switch, an unmanaged switch. You can select. So I just kind of wanted to show you what they look like. You guys already know an access point. So my question for you is that, is an access point the same as a wireless router, or vice versa? Is an access point the same, is an AP the same as a wireless router?
I think they function the same way.
They look the same.
Yeah.
So some access point cannot route. At home, they are the same. Okay? Because people are like, oh, connect to my access point. This is the Wi-Fi key, right? At home, it's two in the same appliance. But in most businesses, an access point is not a wireless router. Okay? So when you drive down the parking lot, right, you can still sit in your car and connect to our CCD because they have many access points throughout the campus. Okay, just like how you go down to most city downtown, you have free Wi-Fi, right? They have many access points. But those access points is connecting to a switch and ultimately the wireless router. Okay.
It's like an extender.
Yeah, it's a separate system because that way you would have greater span in your wireless network. So access point allows you to access that network. Understand? Where wireless router routes your data wirelessly. So at home, they're the same, but in many cases, in business environments, they're not. Okay? So find an access point. Remember what I said, right? Or if you don't know, you want something that has omni antenna that's 360-degree, all directional antenna. Some of them are built inside and they don't have antenna that's visible outside. You want them to also be in the latest standard, right? Like dual band now. You have 2.4 and 5. So the higher the frequency, the shorter the distance. Some of them also have repeater that's built in. And a lot of the industrial access point, if you go down, if you drive downtown, sometimes you see one, like they would put, like, it looks like a light pole, and then you see this box, and then you see power solar panel. They are low powered systems that is, solar charged. It's really designed to have wear and tear with all weather, right? So you have rain, you still have systems that are running, stuff like that. So it really depends. And most of the time when you walk across, you will see some access point. They mount it where you can't reach so that way you don't tear it down physically. So, but yeah, they run from a few $100s all the way to thousands. It depends. Okay. So you guys kind of see now the difference. And then some of them have antenna. Now, I would use antenna that's directional if I don't want certain area to have access to it. So for example, in the hospital, you want to use directional antenna because you don't want the signal to intervene with like MRI systems in some part of the hospital. So you want to have access point that would have directional. So you only aim it for a certain direction, like maybe the nurse's wing. But then when it goes into like X-ray and MRI system, you don't want other signal to intervene because ultimately they're still on the same spectrum.
I have a question.
Sure.
I use Spectrum when they brought the router. They added something called Wi-Fi 7.
Yeah, so that's just the next Wi-Fi standard.
And then when I'm looking for the access point, it's also using
Wi-Fi 6.
7.
7, yeah. So the current one is 7, but it has backward compatibility. So if you buy an old laptop that's Wi-Fi 6, it's able to connect to Wi-Fi 7. But ultimately, it's not optimal, right? So in technology, we want optimal communication if we're on the same standard. So like I said, right, you can buy a sport car, but you really have to drive it on the super highway to really optimize that sport car. So everything has to be on the same thing. But they know that the industry knows that you might not upgrade everything right now, right? Or sometimes you don't have the capability to do that financially or, supplies to do that. So, yeah, eventually everybody will be on Wi-Fi 7 and not 6 anymore. Sure. So at home, yeah, ideally you should be on Wi-Fi 7, but you might not have everything on Wi-Fi 7 right now. Okay, so we talked about a little bit about wide area network. When you're entering another network, right, or when you're connecting to, like, the internet is considered WAN. So when you see the cloud symbol, that really just means that you are in another network outside of your own, beyond it, right? So in order to connect, you need a few things. One, we talked about the router, right? That's like the systems that gets you into the freeway and from the freeway. Okay? And the freeway is like others, service provider, the networks, other networks that you connect to. There's also a thing called a gateway. A gateway typically now is your router. But back in the day, and in some cases, it's a computer systems that takes you from your network to the next. It's like leaving your gate to go outside. It's like that. And when we're using a switch that functions as a router, it uses what we call L3 or layer 3 or layer 4 switch. That just means that it can route and it can go beyond. And we'll come back to this when we talk about OSI. It really refer to the OSI layer. Okay, so some switch, just like how you have wireless router with access point, some switch can route and switch. But the switch job is to bring, right, communication in that segment, one computer to the next, and so on. Now, in a network, you have to get a router to a switch, okay? So, and your computer is connecting to a switch. So if you access a website, it sends it to the switch and then the router and then other routers and then the domain. Okay. So without the router, you cannot have an internet or a WAN. So in a peer-to-peer environment, you have one system that's one peer and another system that's another peer. Like we talked about your tablet and your iPhone airdropping, right? I airdrop a picture from one device to another. It's parallel. It's the same level, right? Like how you and your classmates are peers. So in a network environment, sometimes in a home network, you have a peer-to-peer environment. You don't have a server that controls your files, your access, and so on. Some people do. Or when you go to like a coffee shop or internet cafe is not too popular here, right? You typically would see that in other nations where people go there to use their internet. And all their systems are peer-to-peer connected to their wireless network. Very similar to your home. So you can access your email. I don't recommend it though. But, typically, they don't really control security on those systems. So just know that any public system that you access, potentially your private information can be viewed. So just be mindful about that. If you absolutely need to, then you have to, right?
Layer 4 and 5, 3 and 4.
3 and 4. So the 3 allows you to get from one network to another. The layer of 4 allows you to do other things like to encrypt data, to so there's another layer that's in charge of the transmission part. So things that you see with layer 4 is that when you are using HTTPS, which is a web type of service, but it encrypts your data as you access bill pay or something like that. We'll come back to OSI in the next round. Okay, so today we're going to draw a topology. So topology consists of systems and how they are connected. So the physical topology is really the physical arrangement of your system. Like these right here, right? There are cable, they are connected by cable and they're physically connecting to through the wall, right? You can see these little drop right here. So when we say a drop, that's a connection into the wall, and they run that all the cables back into the switch. Okay. And physical arrangement is also pertain to your room layout, right? Like I talked about how some cable we need to run it through the fault ceiling like this one, and then into the elevator shaft to go, maybe into other area of the building. So that's really a physical topology on how the systems are connected and they're shown as a layout. Now, in a logical topology, I shouldn't have the S there. It really shows the data flow, how the data goes from one part of the network to the next, right? Like I have all the system sending data to the server and then the server respond back. And that would be illustrating. And so it basically is not tied to the physical arrangement of the building and how the room is laid out. It just shows server and all the system with the arrow or lines connected to it. So that's a logical topology. So in most networks, they have both, right? And so if you become a network engineer, this is your job, is to look at the topology and to improve it, right? Or create a new layout. So let's say that you are hired as a new network engineer for a brand new company. You have to come up with how the network is set up. So you would draw a physical topology, and then you also draw a logical topology. Now, from a security perspective, I come in and I talk to your network engineers and I ask for a layout. So when I do an audit, I look at that and I will tell you what's wrong. How potentially they can get in, what's the weakness of your network, and then you improve, right? So network engineers, typically they handle like the design of the network, how that design can expand. So let's say that the company grew and they're buying or they're building another location. Yeah, that's the job of the network engineers. So how fast can you go from a technician to an engineer? It depends on how good you are at networking. Okay? Or as an analyst going into an engineer. I've had many former students that started in IT and they did network engineering and then they transferred to security engineer. So there's a correlation in that because you understand the flow of the data and you know how to protect the data. Okay, so let's talk about specific topology. So let's say that I have a computer and I connect that computer to another computer using a cable, right? And I connect that second computer to the third computer and that third computer to the fourth computer. Traditionally, we did this because there's no better way, right? So a bus technology, just think of it like a line that's flowing from one to the next, and then eventually to the end, right? So it might be easy to install and it was low cost, but most of the times if you have to, then you use it, but typically we don't use bus topology anymore. The drawback is that if I'm sending data from the first to the second to the third to the fourth, If somewhere in between these two computers are down, I don't get data from the first to the fourth. You understand? Because it flows down one to the next, to the next, to the next. Okay. You sometimes see bus technology or topology being implemented to relay data. Old school systems do this. So from a security perspective, the attacker, they are going to look for target. So they're going to say, oh, that's the way the data flows. I'm just going to attack this, the first one, or the middle guy, right? If I can find any information to target them, then I'll take you out so you don't receive any data. Okay. So it doesn't have fault tolerance. So when we say fault tolerance, that means that there's no backup ways or alternative ways to stay alive or connected. We're halfway there, so. Any question? We only have 20 questions. So in networking, you want to be always connected at 99.999999979%, right? As much as possible, you want to have fault tolerance. So in the case if you have interruption, you have an alternative systems or communication ways. You want to have performance, which is throughput. That means that you want to have responsive, fast communication, right? And you don't want latency. Latency, the word latency contains the term late, that just slows down, right? So if you have latency, that means that there's a lag in your network or slowdown. Okay. So that's the goal, objective for all network people. So if you have everything, then you're golden, right? So an analyst in the network environment typically look at those things. How can I achieve performance? How can I achieve fault tolerance? How can I achieve that to make sure that I understand, I analyze it, and I make sure that things don't happen to my network. Okay. And then work with the engineer to redesign to have better ways. It's kind of like if they build the freeway system better, right? You have less traffic, and less traffic means happier people, and more cars going to be able to travel through it. A lot of things. So there's a lot of benefit in networking and making sure that we drive performance and improvement with it. So, all right. So I'm going to bring 11 down. Then we're doing assignment for day 1. So the star topology is what you have at home. Everything is connected to your wireless router, just like how you draw a star with lines, right? Took all my markers in here. Yeah, so you would have a central point and everything is stemmed from it, right? Your wireless router does that. You connect your tablet to your wireless router to access the printer who is connected to your wireless router to share files with your laptop, right? So star topology connect to one system that is central, the central point. We can do this. The benefit is that you can just throw in, like, if I visit your home, I'll be like, let me access your wireless, right? So I can access the internet, or let me print, right? So you would just give me access to your wireless. So you can quickly add a system or remove that system. So if I want to reject, I just block it from the router, right? Yeah, if you guys are not MAC filtering on your wireless router, then you're not controlling security for your wireless. We can talk about that later when we do the wireless lab. And if I have one system that is not physically connected with the cable, the rest still stays alive, right? But the downside is that if your wireless router goes down, what happens? Nobody gets connection, right? So from an attacker standpoint, I'm going to look at your topology. If you have a star topology, guess what I'm going to target? Your central star, right? The center of your star. If that's the system that you're connecting to, I'm going to wipe that out and you're done. right? So now if I troubleshoot, if you don't have internet connection to your other your tablets or your mobile devices, I want to make sure that you do. So I just reboot your router, or I reconfigure the router or troubleshoot the router, right? So that way you stay connected. So it's easy to troubleshoot. You do have higher costs in the physical cable because you have everything connected to that central hub. More or less depends. You have a single point failure, I said that, right? Your access point or your wireless router is the center of your network. So if that is down, power connection or something gets disconnected or it's interrupted, nothing is communicated. Question? It is on campus. If you look at day one, the first page, when you click on that module, it is on. I'll show you that right now. So if you look at day one, the notes are on there, which is this document, right? So if you look at star topology, and you guys can navigate through navigation pane, star topology, it shows that here. So if you use day one, when you look at modules or home, I said it, your notes is here. It says networks. Click on the page and then you can download it or view it here. Any question? Okay, so what we're gonna do is we are going to make a star topology. This is like preview to your lab. Or we're gonna look at their template. So if you press Control and you click the link there, let me see if we can search it. It might have. It should. I just checked the link like a week ago and it worked, but they might have changed the content. You might have to search for it. Let's see if we search for network. Okay. Yeah, so if you land on the page on the right-hand side, if you just search for network for number 13. So for number 13, when you click the link, right, it takes you to the main page of that tool. So this is an online tool. So it looks like this, right? So on the right side where it says filter and search, you can just type in network and it's going to give you the network diagram. You can click browse template. And these are like pre-made network diagram that the tool provides. Okay. And so what you can see is you can see a lot of like different types of diagram. So if I want like a star, okay, look at one that has a central point. So like this one. See how everything is connected to their hub there wirelessly or their access point? Everything else is kind of, okay, let me see. This one is also like a star. So you can see star network template. You can also search for that. You can click this one. Okay, so again, right, go to their main page, search for network, and click on the result. And then you're gonna say browse template, and you can see the star. So why is it a star? Is because you see this one appliance right here, likely that's an uplink switch, or it could be like a router built in, right? You would see that everything, like the 3 segment of the network is centralizing to that, right? There's one point that everything is connected to it. You also see that over here too, this one too. But the star one is like this. In a business environment, it's like this. This is more like a home. Okay? So now you can see what a topology looks like. Any question? So in the lab, we're gonna draw. So once you have it, okay, oops, let's come back here. So I'm gonna click on the star. You can screenshot this and paste it to your assignment. So we can do control print screen, or I can use snip. So I can call up snip and then click new, and I'm gonna drag it. So when you do that, you basically copy, put that onto the clipboard, and then I can go to number 13 and I can do control V. But we can do print screen if that works. So I put a link on how to print screen, right? So the reason why I have you do this is when you look back at your assignment 2 weeks from now or a year from now, you know what a star topology looks like without drawing it. Okay. And then in it, you would see that there's little substar, right? Everything is connected to the hub. Everything is connected to that's an unmanaged switch, typically, right? Everything is connected to this appliance, and then in that, the segment is connected to a central system, which is the main one up here, okay? This system right here. Any questions? You need help finding it? There are many tools that you can use. Okay. This is free. Some of them you have to create an account to be able to access it. And it stores your data. Like it gives you like 2 or 3 free drawings. And it saves it to your account on the cloud.
Yes.
But if you pay for subscription for some of them, they would give you unlimited drawings, or and there's different tier in some of them. Back in the day, we would use like other applications that you have to pay for, but now you can use cloud tools like this. So if you want to design a network, you can definitely use this link, right? Just keep in mind that you are limited to a couple of drawings through the free option, and then you can buy more through the subscription. Okay. So now we're going to touch on ring or mesh. So a ring is a circular bus. So if I connect system 1 to 2, 2 to 3, 3 to 4, and then 4, I reconnect it back to 1, it becomes a circle. That is a ring. Ring topology was very popular back in the day. This is how we can send things from one system to the next and then back to the original system. The downside of that, similar to the bus, is that you do have a little bit less fault tolerance, but the in-between system 2 and 3, if they're out, you cannot get it to the rest. You can still get 1 to 4, however, going the other way if you have a bidirectional ring. So other point-to-point topology, right? Oh, I'm sorry. You can have a mesh. So mesh is kind of like a star, but then you have interconnection in between those, right? So if you draw like the star, right? Like the typical way that you draw a star with lines across, then you would see a mesh. So mesh topology allows you to use a star and then interconnect the systems that are connecting to the central point. So that way you would have, but you would need to spend more on cable and other things. So in reference to that, right? So this is a ring. You might have a directional ring where I can go from 1 to 2 to 3 to 4, back to 1. Now the downside of that is these 2 can go out, and that will be not sending. I can send the other way if I have a bidirectional. So it can circulate the data the other way, right? In case these two are out. So that's the benefit between ring and compared to a bus. And then if I have a mesh, it will be like this. So not that only I can connect the system 1 to 2 to 3 to 4 back to 1, but I can connect, right, 1 to 3, right, 2 to 4, and so on. So you tend to see a lot of the servers are star based, and sometimes they are also like a hybrid where you would have a mesh and a star. A lot of the times we are put it in hierarchy structure, so you tend to see that. So you would have a star and a mesh combined. And then you also have a tree type of topology. So for the point-to-point topology, like what I said, right? If you have access point to wireless router, that's a point-to-point. So anytime you have one system to the next system, that's a point-to-point. Okay, so an example of a point-to-point. I have a router connecting to other routers, right? One router 1 to router 2, that's common. And eventually, if you keep router 2 to router 3, that's like a bus. But if you might have a mesh where router 1 to router 2, router 2 to router 4, router 2 to router 3, and so on. But ultimately, it's one system to the next. You might have one, so to multiple point, you might have 1 to 5 computers or 16 computers, or, typically you would see 8 ports, 16 ports, 24 ports, and so on. So at home, you have a wireless router, but in front of the wireless router, you see the Ethernet connection, so you can have cable connected to your router, your wireless router. So that's point to multiple point, right? So a star is point to multiple point, whereas a bus or a ring is point to point. Okay, so how do we select the topology, right? You have to really consider the cost of cabling and connection and maintenance in that, right? So if your cable is bad, you have to replace cable. Also, how the interface, like your network interface card or the wireless adapter that you have. So cost of hardware and maintenance. How easy it is to install, that's ideal for us, right? Because that means that you can troubleshoot by reinstalling. How easy it is to maintain. So the majority of the things still today is going to be copper. And I want to say, maybe when I'm done teaching and maybe dead, another professor would say the majority of the media that we use for connection is fiber. It took us a long time to get to fiber connection. Okay, so for maintenance, copper maintenance is fairly low in cost. So if you're using a coaxial cable, then you are using a copper cable. If you're using Ethernet cable, then you're using copper cable. So the other class, they threw a bunch of cables at your application. So you're familiar with Ethernet. You're gonna do this tomorrow, right? Making Ethernet cable. When you look inside, right, it is copper wire inside your connector. I'm using a push through, so it's easy for the student to do that. So you have tools to do this. This looks like a telephone cable, but the difference is that your connector is an RJ45 and it is a wider connector, right? This one, right? So this is a straight through cable. That means that I can connect one to multiple points. I can connect my computer to a switch. If you are connecting the same devices, like computer to computer, you use a crossover cable. They are wired differently. So tomorrow I'm going to give you an option. You can make a crossover cable or you can make a straight through cable. And the arrangement of the copper, color copper inside is different. Okay? So we'll talk about that more tomorrow for day 2. But again, most of our networks today are still using copper, including your home networks, including your service provider network, right? A lot of their stuff now is probably fiber. So fiber is light-based cabling. It uses laser or LED. Okay. That means that light travels faster in sending data and it's reliable and consistent. So you want to use fiber ultimately down the line. And then also a security requirement. But so let's bring 17 down. We're almost done. Okay. Another term that you might get is CAN, which is campus area network. You typically see this when you go to university, right? You walk around, they have many buildings, right? Like they have halls. So if you go to UCR, I used to go to UCR, you have Sproul Hall, which is now very old, right? You have Winston Chung Hall, like they would name the hall after the people who sponsor that hall, like donations, foundations, or famous people that, etc. So typical that you see that they would have tall rise buildings, right? Which comprise of the networks within themselves, and then those get connected. So here's a trick question for you. If I have one building, let's say downtown Moreno Valley, for offices, and I have another building, how do I connect those buildings together? What kind of cable do I use? Do I use the coaxial, the one that you use for cable TV? Do I use Ethernet cable? Do I use fiber cable? What cable do I use? I don't want to use completely wireless because wireless still have to be connected back to the cable, like what you see with your wireless router. So what kind of cable do I use?
What was the?
So I can have the coaxial, which is what you use for cable TV, like the cable box, Ethernet cable, or fiber cable.
Also.
So back in the day, that will be coaxial because it's cheap, right? You don't want to use Ethernet because Ethernet is limited to 100 meters. Typically, in a campus environment, you might have buildings that are far from other buildings, right? Like, if you go to a big university, you're gonna walk like a couple of miles before you get to some of the other hall, right? So the rule of thumb is that when you go building to building, you use fiber connection, right? It's gonna be fast, it's gonna be reliable. Now, also, if you're going from one floor to the next, you should also use fiber. A lot of my students are like, why can't you use Ethernet? Well, copper doesn't send as fast. And then when you put it through the elevator shaft, you might have a 15-floor building, right? If you ever go to like Metro City, like New York, you're going to see tall rise that's going to have like 30-something floors. How are you going to connect from first floor to the top floor? Right? Those people who own the apartments at the top floor, they're like residential king suite apartment, right? They still gonna have to have internet connections. So the way that you connect one floor to the next is with fiber. Okay. So if you want to get into communication installation, fiber technician makes good money. You see them all the time around here. I see them all the time to work. Yeah.
I just had a question about the fiber because you said it was recent for here. Was it just like in the States or like his?
Yeah, I think a push for that now is there's funding for a lot of the states in the rural states, like the southern states, some of the Midwest state. California, you see a lot of fiber connection because the service provider here supports it, But in the states where you have a lot of rural town, yeah, our government funds billions of dollars for companies and county and city offices to be able to push for that because with fiber you have and then you would have cell towers and things for those rural communications area. You would be surprised, right? Like how advanced we are in technology, but you do have people in a very rural area that don't have fast connection.
Okay, I only asked too because I have a friend in Europe, specifically in Sweden, who said that like he was making fun of us here because he's like we had fiber here like 10, 15
Yeah.
years ago, you know. Like,
So there's a lot of pushback with FCC in that, right? They control communications and the regulations beyond the standards. So IEEE is the organization that build out industry standards, but in a lot of the region, you still have to consider things like that will be passed for safety, things, there's also like the migration in how we would look at the current infrastructure. You can't just push fiber 100%, just like how we went 4G much later compared to Asia and Europe.
that's true.
And so therefore you would have more mobile devices that were 5G and 4G way before in other parts of the world, way before North America. We are always slightly behind because the way that we regulate that for Canada and United States is a little different in how technology for communication would be. And then also the standards that gets approved for that, right? And you see that with biometrics and other things. If you ask people who lived in India, biometrics been implemented for banks and stuff there for a long time. But we just started, yeah, as you can see, with our mobile devices. So the way that we built stuff here is a little different, for sure. Yeah, and when we get further on, you're gonna see that like with old technology, it was like that as well. Communication systems has always been and there's concern about an implementation with how technology is used for North America as well. Okay, last few question now, right? What is the purpose of storage area network? Remember what I said about like you can go home, you can connect to your wireless router, and then you can just automatically save all your data to a server at home. So these systems can be bought, and they're like computers with storage, like 4 terabyte, 10 terabyte, however much you want, and you can put your data there instead of iCloud or whatnot, right? They're making it very difficult for you to back up data to the local systems because I try to do that for my parents because they have iPhone. I use Android, so it's easy for me. But for the iPhone part, like just transfer it to a PC. That can be cumbersome if you don't know how to do that, right? Anyway, you can set up a storage area network, which is like a system that where you can centralize all your data. And so if my family members can access it, I can share it with my family member to be able to download the files that I have and vice versa for the business, right? You can do that. Now the true cost is going to be your storage. Okay. SSD is fairly affordable given that AI is not going to drive up the price further. Just like how they talk about gas, right? Like, okay, so are they going to lower the price now that supposedly we have access to gasoline a little bit more in the United States, but because the economy on how it drive up the price and they want to keep the baseline higher. And then you can also manage data. I have a lot of friends that stopped using Netflix, and then their hobby is to take the old DVDs that they have and they convert it digitize it, and then they stream it directly from their server. And they can access it anywhere as long as they have access to their wireless network. So you can authenticate to it over the internet and be able to watch your movie if you're traveling. That way you don't have to pay the service fee for these streaming services. I like the convenience of Netflix and I like the variation that Netflix gives me. So I'm not there yet, right? And like even if you have a good collection of movies, like don't you want a variation, diversity in and then also like their argument is that the service provider, they have an algorithm to really feed you, right? Like what they want you to watch. They were like, yeah, we want to have control of what we watch, but that's the whole point. Is for me, it's interesting that I can be given a choice in something different and new that I would never own, right? Uh, but so if you have old DVDs, there are websites that will buy it back for a lot of money, and these people, like my friends, would buy it from you.
So-
I was like, yeah, I have a bunch of boxes that have old DVDs and Blu-ray. Okay, so with that, we are going to look for storage area network that is SAN. So you can go open up your Chrome browser or any browser that you're using. You can search for storage area network. And you can see they are higher in price than your typical system because, like I said, the cost is going to be the storage. And they look like a regular computer, but it has the capability for you to centralize your store and manage. So there would be features for you to do that. Yes.
Are these the things that are the racks that are in the data center? So it's like
Yeah. So, well, the most of the data center racks can be SAN. Companies don't necessarily implement SAN because of the cost of it. So if you buy a box that has that capability already, it's gonna be expensive. It's kind of like you buy a car with extra feature. Okay. Whereas you can buy a very low end car and then you can add the feature yourself. So you can buy a server and then make it into a storage server by buying, RAID drives or whatever drives that you want to use. So you can build that out. But these, yeah, you're correct. They are mounted onto the rack ready. And some of them are tower because companies sometimes they don't want things on the rack and they don't have their own data center within. They might just have like a closet that will be like their server room or something like that, which is typical. Yeah, you're gonna see that they are much higher in price than your regular computer. So can I buy a powerful computer and add a bunch of drives to it and call it my storage area network? You can, right? A lot of these have software that you can manage your files and things like that, but you can convert and install the software yourself. So it really depends on what you want to do. Now, that's different than network attached storage, which is another story, right? NAS is different than SAN. It's so confusing. Any question? The good thing about buying from a vendor is that they service it with the warranty. So in the case if it malfunctioned the first year, they would send technician out that contract with Lenovo and be able to help you. You don't have to fix it yourself. Or they'll take the equipment back and give you new ones. Okay. So I encourage you to go through. I kind of fast forward, but I want to touch on a couple more things that we kind of not mentioned in the assignment. So whenever you hear the network backbone is like the main area of your network. That's where all your major communication systems are connected, right? Typically, this is at the corporate office or the office that would house a lot of the network systems that connect to the rest. Here, right, they have, so your backbone, it could be to the local, and it also, if you have multiple branches, it can also be to, the headquarter or whatnot. But you're gonna see major network appliances like your router, your switch, your servers connected there. So your backbone is like the main area where all your systems are connected. So your communication systems connect there. Okay. And then when I say a network segment, you are sitting in a network segment. That's just a section of your network where that group of systems are connected. Right? And it could be separate or combined to the rest. So segments are important because when from a security perspective, the attacker has to enter from somewhere and you have to pinpoint where they come from, right? It could be this segment, it could be another segment. So the address really identify where you're coming from. It's kind of like you're coming to visit me, right? The system is gonna know like which zip code you're coming from, right? How fast you're getting there, right? What other systems that you have used to get there, like what car you drive, what freeway, and so on. So that's how it works in communication. And so the goal is that, we identify like the risk of the systems, how, someone can jeopardize our network or circumventing our network. But security does not exist without networking. So I tell my students, and I'm going to tell you the same. If you want to be strong in security, you have to be strong in networking, period. Because everything connects. Okay. You cannot be good in security without being good in networking. A lot of them struggle in this, but they understand the terminology in security, but everything comes back in communication. Okay.
Even a lot of these or I was doing questions on the 8+ again. A lot of stuff on here is on the 8+.
Yeah.
Even that.
So these classes, they're gonna repeat a lot of the things. You're gonna keep hearing them, and then eventually it's gonna be very normal. The same, right? Like it just expand in a certain concept. So the network areas, we're gonna expand in how these things are communicated. Okay, I'm gonna stop recording.